Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Hello.
Yes, sir. Yes,
Oh,
you are
fine.
audible.
Thanks, Pritam.
Good afternoon, sir.
Okay, so we'll start. We'll start from linear transformation. So, okay, so let me recall what is linear transformation. Okay, so so I guess my screen is visible to all of you. So, okay,
Yes,
so
sir. Yes.
so as you know, suppose we have two vector spaces, so V and W. So in vector space, we have two operations. So that is, one is addition, which is basically from V plus V to V. It's a map. And another one is multiplication, which is from let's say, so in this course basically we are dealing with R vector spaces. So it's a map from so we want a map which preserve both the structure. So in some sense T from V to W, it's a map which preserve both the structure, that is addition structure, and as well as the multiplication structure. So mathematically these should satisfy these two conditions. The first one is this T is additive, that is V1 V2 is same as T of V1 plus T of V2. And the second condition is it should satisfy, it should preserve the multiplicative structure. So the scalar, so here the multiplication is basically with the scalars. C times V1 is basically C into T of V1. So if T satisfy these two conditions, then I can say that T is stop me when you have some doubt. T is a linear transformation. Okay, so if T satisfy both these conditions, then I can say that T is linear transformation. So it's more or less what it's saying. So so this is, let's say, V, this is, let's say, W. So I have V1 here, let's say I have V2 here, and I have V1 plus V2 here. So T is a map from V to W. So then you have an image of V1, that is T of V1, and you have image of V2, which is, let's say, T of V2. If I add these two elements, T of V1 and T of V2, then I should get, so this T of V1 plus T of V2, then I should get T of V1. Okay, so this is the image of T of V1 and V2, and similarly you can see like what is going on in this case. Okay.
And both are vector spaces, sir, V and W.
Yes, yes. V and W are vector spaces. Otherwise, this
Sir, could you take some
this
example
addition
and
and
explain?
multiplication has no meaning if,
Sir, could you take some
you don't
example
have.
and explain?
Yes, I'll do. So okay, so one thing is one of the consequences of linear transformation, if T is a linear transformation, Okay, so let me use transformation. Then it takes the zero vector of V2, the zero vector of W. If T is a linear transformation, then T takes the zero vector of V to the zero vector of W. Okay, so that is the one of the implication of a of linear transformations. If I have a linear transformation, then it should satisfy uh, these two conditions. Okay, so this is not a if and only if statement. So if T is a linear transformation, then T of 0 is basically T of is 0. But this the reverse part is not. If T of 0 is 0, that doesn't imply that T is a linear transformation. Okay. So let's say, for example, you can take a map. Let's say R to R, and the map is T of X is X square. So as you can see that T of 0 is 0. So here I am taking R is a vector space with respect to this usual addition and scalar multiplication. So T of 0 is 0, but certainly T is not a linear transformation, because if I take T of, let's say, 1 plus 1, then this is not equal to T of 1 plus T of 1, because T of 1 plus 1, which is basically T of 2, and this is 4, but T of 1 is 1 and T of 1 is also 1, so this 1 plus 1 is 2. So as you can see, the first condition doesn't hold for this this given map. So as you can see, T of 0 is 0, but T is not a linear transformation. So just now I said, if T is a linear transformation, that implies that T of 0 is 0. But if T of 0 is 0, that doesn't imply that T is a linear transformation. Okay. So as you can see, this is a example of the above fact. Okay, here T of 0 is 0, but T is not a linear transformation. So again, we can take, let's say, some another example. Let's say T of R square. Similarly, R square is a vector space with respect to usual addition and scalar multiplication. So now you take this map. Right. So this is a map from R2 to R2. So my claim is this is a linear transformation. Okay. So the claim, what I want to show, T is a linear transformation. So how? So to show T is a linear transformation, I have to show that T satisfies both these two conditions. Okay. So let's pick two arbitrary element of R2. Let's say V1 is X1, Y1, and V2 say X2, Y2. What I want to show, the first thing I want to show that T of V1 plus V2 is nothing but T of V1 plus T of V2, right? This is what I want to show to prove that T is a linear transformation. Okay. So what is V1 plus V2? So this is nothing but X1 plus X2 and Y1 plus Y2. Okay, so if I So then first thing I have to evaluate T of V1 plus V2. Okay, so what is that? This is nothing but T of x1 plus x2 y1 plus y2. And by definition, the way we have defined T, this is nothing but x1 plus x2 plus y1 plus y2, and the second coordinate is x1 plus x2 minus y1 plus y2. Okay, so this
Sir, where we are adding V1 plus V2, we could have done
Yes.
coordinate-wise addition, like x1 plus x2 is the coordinate of V1. No, x1, y1. Okay, fine.
Yeah.
Proceed, sir. Sorry.
Yes. So this is T of V1 plus V2. Okay. So the next thing is, so what we want to show? We want to show this equality. Okay. So we have calculated the left hand side. So we need to calculate the right hand side. Okay. So what is T of V1? So T of V1 is T of x1 y1, which is nothing but x1 plus y1, x1 and minus y1. And similarly, if you compute T of V2, it's nothing but x2 plus y2, x2 minus y2. Okay, and if you add T of V1 and V2, you can check, you will get this element. Okay. So what basically we proved? We proved that T of V1 plus V2 is nothing but T of V1 plus T of V2. Okay, so the first condition is true for this map. Okay. So the first condition holds. The condition 1. Okay, T is additive. So the next thing we need to show the second condition. So what is the second condition? T of C V1 it's C times T of V1. Okay, so the first step is we need to compute what is T of V1. So this is nothing but C x1 times C y1, right? So then T of C V1, which is nothing but C x1 C y1, which is nothing but C x1 minus, sorry, by definition. So this is the definition. This is how we define T. So I'm just applying the definition. And you can take C from this this tuple. So this is nothing but, and you can see that this particular quantity is nothing but C of x1 y1, which is nothing but, so we are done. Okay, so we are done. So we checked both the condition, and as we can see, T satisfies both the conditions. Okay, so that means T is a linear transformation.
Do we need to check zero element also?
Sorry,
Do we need to check zero element also? Zero,
what do you mean by zero element?
like zero vector, like just in previous slide we are explaining, no, that zero vector.
Sorry,
Zero vector.
No, zero vector
No.
is required for subscript, I think.
Okay.
No, what I'm saying, if T is a linear transformation, then T takes the zero vector to the zero vector. But certainly we have proved that T is a linear transformation. So then why we need to check that it takes the zero vector to zero vector? If T is a linear transformation, then it has to take the zero vector to the zero vector. So we have proved much more than that. Okay, we have proved that T is a linear transformation. So as
Basically, that is
so,
for the proof of subspace. Huh?
Yes, I think he's
sorry.
confusing between
Yeah,
linear
only for a
transformation.
subspace. This is already a vector space. So zero vector is existing.
Okay. So okay, okay, so the next, let's say another example, let's say R2, R32.
Sir, at this stage, can you go back to the opening statements you made it today? The first 4 lines. As a wrap up, can you revisit those things?
Sorry.
Yeah, this one, yeah, this little more scroll up. After we finishing these 2
Sorry.
examples, can you just walk us through the statements, what you made first? Yeah, from here, V and W. You are telling about
No, like, so the thing is, okay. Yes.
It was sounding
Hello?
more
Am I audible?
abstract. Now probably it will be clear.
Yes, you are audible.
Yes.
Okay, so the thing is, what basically we are doing, we have a map. So as I said, we have a map. Okay, so the map is given here. So the first one is this one. This is a map from a vector space V to W. In this case, B and W, they are same. So what we want to do, we want to check whether this map is a linear transformation or not. Okay, that is what we want to check. Okay, so to check whether T is a linear transformation or not, we need to check these 2 conditions. Okay, so the first is T is additive. So here what basically we check that T is not additive. Right? So if T is a linear transformation, if and only if T satisfies both the conditions. Okay, not one of them. Okay, so since T doesn't satisfy the first condition, okay, then I can say that T is not a linear transformation. Okay, because we need T to satisfy both these 2 conditions. Okay, and again, in the second example, we again took some map from V to W. So again, in this case, V and W, they are basically same. Okay, so again, we have to follow the same procedure. We have to check that T is additive map, and as well as T satisfy the multiplicative structure. Okay, and we saw that T satisfies both the condition. Okay, T is basically, so here we prove that T is additive. Okay, and here we prove that T is in some sense T preserve the scalar multiplication. Okay, so T satisfies both the conditions. Okay, so that's why we can say that T is a linear map. Okay, please mute yourself. Okay, so let's say I have some map X, Y, Z. It's basically X plus 1 and Y minus Z. Okay, this is my map. Okay, so my question is whether this.
You are not audible.
You are not audible.
Sir, your voice is not coming clearly.
Sorry?
You are not
You are
audible.
not
sir.
audible, sir.
Sir, your voice is breaking.
Okay, now is it fine? Hello?
Cracking,
No,
cracking. It's
No,
cracking.
sir.
Hello?
No, sir.
Yeah.
No, sir.
Okay. Just a minute.
I think there is a network issue.
Yeah, probably.
It is okay now.
Is it okay now?
Yes, sir.
Okay, so just yeah, I guess there is some network because it's saying that many times, saying that my internet connection is not stable. Okay, so we are facing some audio issues. Okay, so so my question is whether T is a linear transformation or not. Okay, so how you should start solving this one?
By taking two vectors, sir, like the way you did in last example. Hello.
Yeah, so that is one way, but okay, so here actually I mentioned one thing. Okay, so I mentioned one thing that if T is a linear transformation, okay.
So it is not a, sir, it is not a linear
if
transformation.
T
Whatever
is
it
a
is,
linear transformation.
it is not a linear transformator. Whatever you have
Yeah,
given,
yeah, correct.
because it is
But
not, it is
Let
not
him,
mapping 0, 0
that
to
that
a,
certainly
let
I
him
know.
explain the approach now, yeah.
No, I want the reason why it.
so it is not mapping 0, 0 to 0, 0.
You are not audible.
Your voice is
Okay, I'm
breaking.
not audible.
Yes, sir, you are.
So it is not a linear transformation.
So it is not a linear transform because it is not matching 0, 0 to 0, 0.
Okay, just a minute. Like I'm just a minute.
Please explain, sir.
Just give me a minute. Yeah, so now am I audible? Again, like I actually I'm checking the internet speed. Okay.
Yes, sir, you are audible.
So one thing I said earlier, that if T is a linear transformation, then it takes the zero vector to the zero vector, right? So one thing you can see
your
here,
screen is
that if you take the
not
zero
visible.
vector
Your screen is not
in
visible.
R square, T of 0, 0, sorry,
Yeah, it's okay.
Hello.
Screen was not visible.
now.
hello, sorry.
Your screen was not visible. Now it's good.
No, sir, it's a fine.
Okay,
Fine.
fine.
Visible, sir.
Yeah. Okay, so if you compute T of 0, 0, 0, then what you will get? So
1, 0.
it's basically 1, 0. Okay, so as you can see, T of 0, 0, 0 is not equal to 0, 0. Right, so it's T. So in some sense, T is not taking the zero vector of R3 to the zero vector of R2. Okay. So,
Sir, this was,
directly
sir,
from here, I can say that T is not a linear transformation. Okay.
hello, sir, am I audible?
Hello.
Yeah, you are audible.
Yes, yes.
Sir, this was my precise question, that before checking the additive property and scalar
Hello.
multiplication. Hello, sir, am I audible?
Yes, you are.
You are audible.
Sir, this was my precise question, that every time, whether before checking additive and additive property and scalar multiplicative property, do we need to check the presence of zero vector in every problem? That was my precise question last time also.
I think you're audible for us now, sir.
Yes, I think sir has lost connection.
Yeah, sir is not having connection, so just
Yes,
wait.
yes. Yeah, yeah.
Anyway,
Thank-
it was a good point
Yeah.
actually. Thanks.
Yes.
Thanks for the point, man.
yeah, thank you.
Hello. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Now you're
Okay.
audible, sir.
Okay, yeah. So yeah,
Start.
actually I'm facing some connection issue. So yeah.
Start sharing your screen, sir.
Yes. Okay. Okay, just a minute. I have to tell them to make me co-host again.
So in the meantime, can I ask a question? Hello.
He is making a call to them.
Yes, please.
Yes, sir.
I wanted to ask a question. Hello.
Yeah, hello.
Can I ask a question regarding the mock test?
Yes.
Actually, in the 12th question in the mock, it was written about null space of the linear transformation. But actually, I think it was the null space of the matrix concerned. So the question was about the null space of the linear transformation, whereas in the question, the element mentioned was the null space of the matrix. So I think the question should have been about null space of the matrix, if I'm not wrong. I just wanted to clarify that.
Okay, so just a minute. Let me open the
12th
mock
question of the
paper.
mock. 12th question.
Yes.
It's the null space of the matrix, right? Not the linear transformation. Null space of the linear transformation
Question
would be
number
the
12,
null.
right?
Yes.
Yes. No. It's a null space of the linear transformation.
Null space of the linear transformation would be, sir, null space of the matrix multiplied by the basis, right, sir? The
What do
question
you mean
should
by
be
null space of the linear transformation is?
null
Hello?
space, the basis of the null space of the
Hello?
linear transformation. Hello? Hello? The basis of the null space of
hello?
the linear transformation. Yes. Am I
Hello?
audible, sir? Hello?
Yes,
you
you
are
are
audible.
audible. Yeah, you are audible. Yeah.
I was saying the null space of the the basis of the null space of the linear transformation is the null space of the matrix multiplied by the basis of the this domain, if I'm not wrong.
No, if you are taking actually the standard basis, okay, so then certainly it's basically the null space of that matrix. Okay. So if you are taking the matrix representation of the linear transformation with respect to the standard basis, then the null space of the linear transformation is basically the null space of the matrix.
Yes. So here we are because we are taking the standard ordered basis, that's why we can say that the null space of the matrix is the same as the null space of the linear transformation.
Yes, true.
Okay.
Sir, sir, let us continue with the flow, sir, like what we started.
Yeah, that is what I wanted to do.
Yes,
Sir, I have a small
problem.
Coming to that only, you had lost the connection. I was asking that in this problem, R3 to R2. Hello, sir. Hello. Yes, sir. In this problem, R3 to R2.
Yes, please.
R3 to R2. We took the example of 0, and we are saying that 0 to 0 is not mapping. That's why it's not a linear transformation, right? So this was my precise question, that in all questions whether we have to check this 0 to 0 mapping first before going to check.
That's why it's not a linear map. Yeah.
No.
Yes.
I'm saying that this should be our standard practice, that in all questions, first of all, we have to check the mapping of 0 to 0 before checking additive and scalar multiplication. This is my specific question, sir.
Yes, correct.
Yes, we can check.
Sorry. Before checking the
before checking additive and scalar multiplication, do we need to check the mapping of 0 to 0 in all problem?
It's up to you. Like, see, this thing is certainly helpful. Certainly helpful if you want to show that T is not a linear transformation. Okay, because as you know, it's a necessary condition for a efficient. Okay, if T of 0 is not 0, then you can say that T is not a linear transformation. Okay,
as a
if T
thumb rule,
of
we
0
can
is
do
0,
that.
then you cannot say that T is a linear
No,
transformation.
no, I am saying first of all, we will check 0 to
Yeah,
0
you
mapping,
can do that.
0 to
Yeah.
0 mapping, and then we will proceed for additive and scalar multiplication. Is that right? Is that correct approach?
I have
Yeah, so that is what I'm saying. If T of 0 is not equal to 0, then you don't have to check.
Yes, yes.
No, that is depend on what actually you are trying to do. Okay, so the thing is, if you want to prove that T is a linear transformation, okay, so if certainly see if suppose you are checking whether T of 0 is equals to 0 or not. Okay, if T of 0 is 0, okay, then basically you cannot say anything. Okay, you have to check both the conditions. Okay, so if T of 0 is not equal to 0, then you don't have to check both the conditions. You can simply say that T is not a linear.
Okay, sir, understood. Understood.
Okay,
So in the meantime, I have small question, sir.
that is the difference between these two things.
Understood, sir.
Is it clear?
Yes, 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 clear.
Sir, please continue from where we have
Sir,
stopped.
Yeah,
so
yeah.
before the screen comes,
Yeah,
just one small doubt,
Just
sir.
give me a minute. Actually, I'm not able to share my screen. I have to tell them to make me co-host. Okay,
Yes,
just
sir, in the
give me a
meantime.
minute.
Yes, sir.
Okay, sir.
Hello. So while we are waiting for the response, one quick question, sir, to be honest.
Yeah. So let's start. Okay, so so I'm audible, right? Hello.
Yes.
Okay, fine. So okay, so we showed that it's written here is not linear transversal, right? Again, my voice is breaking.
Yes, sir.
Hello.
Yes, sir. Your voice is
Again, it's
breaking.
breaking.
Yes, sir.
Now is it fine or still?
No, sir, voice is breaking.
Hello.
Yes, so like, yeah, so give me some time because again, like, I'm facing actually internet connection. So let me ask whether someone can take the session.
Sir, I think without screen sharing, your voice is fine. But when you share a screen,
But there
it's not good.
is no point, like, I cannot like do anything without sharing the screen, right?
Yes, sir. Actually, your voice is breaking.
Yeah. Actually, yeah, I understand. Yes, it's my connection. I don't know. Like, now the connection is saying like it's quite slow.
And in the meantime, can I ask one small query, sir?
Sorry.
So in the meantime, while we are waiting for the response or trying to switch these, okay, can I ask one small query question?
Yes.
So I had this doubt in the matrix row space, column space. So let's say we have entire matrix
Hmm.
and we have a row space and column space.
Hmm.
So how is it that, let's say, when we are talking about the spanning set. So if the spanning set we are considering separately for a row and column, then how will they be same, sir? Because the dimensions are different, right? Let's say if we are having n, and here in this
No.
case of m by n, we will have
No, there is a difference. Actually, row space and column space, right?
Yes, sir.
They're as a space, they are different. Okay.
Yes, sir.
As a space, if you consider as a space, because some of them, if you take some 3x2 matrix, right? So the row space is basically in what? Well, it's in R2, right?
Yes, sir. I mean 3 by 2 matrix.
Yes, yeah. But the column space is in R3, right? So as a space, they are different.
They are different, right?
But their dimension are basically same. Okay. So this as a space, they are different, but the dimension is same. So,
Dimension here means like the way we are defining as I mean here how do we define the dimension then? If space wise they are different, that I got it. And dimension wise, how do we say that they are different?
no, so you are saying basically you want a proof.
I mean, I am not able to understand the dimensions being same. Vector space will be different. That is clear because their order is different. Like we have n as a one vector space has n dimensions and another one has m.
No,
So,
actually, for that, actually, you need to, okay, so if you want to prove, then basically it's more or less equivalent to prove that this rank of A is basically rank of A transpose, Okay, so that actually requires some calculation to prove whatever you are saying, like to show that this column space is same as the the dimension of column space is same as the dimension of the row space. That is not easy. Okay, so it
So
requires
row space and column space
have same
cannot be the
dimension.
same.
No, they are not same. I'm not saying they're same. I'm saying their rank are same. Okay. So sorry, not rank, their dimension are same. Okay. I'm saying, see, dimension is a number, right? It's a number. So I'm saying their dimension are basically same. Okay. Maybe they are different as a space. Okay. See, dimension of R is same as dimension of a line, right? The line is one dimension. Okay, but line is in R2, but this R is basically it's a one variable thing. It's basically R. Okay, but if you take a line, it's basically in R2. They are not same, but their dimension are same. Okay, that is what I am trying to say. Okay, column space and row space, they are different. Okay, as a space, but their dimension are same. Okay, so to prove this, as I said, it requires some proper definition and like, yeah, there is some, as far as I remember, there is a definition of determinant, and then only you have to define determinant properly. Then probably you can define the rank of A is same as rank of A transpose. Okay, so. So yeah, so that is what so yeah, so that requires a lot of argument to prove the fact that rank of A and rank of A transpose, they are basically same.
The screen is not visible still.
No, I'm not sharing my screen.
Okay.
So I just wait for a few minutes. Subham probably will join and he will take the session.
Sure.
I have a doubt. Is rank of a linear transformation the same as rank of the image of that transformation?
That is the definition of rank of a linear transformation. That is how we define rank of a linear transformation. Okay, so you take image. If you consider the image of a linear transformation, okay, so it's basically a subspace of the codomain, right?
Right.
You have a map from T, which is from V to W. Okay, then if you take the image of T, it's a subspace of W. Okay, and since it is a subspace of W, then we can talk about the dimension of that subspace, and that dimension is precisely the rank of T. That is the definition of rank of T. Okay, that is how we define rank of T. Okay, so it's not like it's one of the equivalent condition of rank. That is precisely the definition of rank.
Sir, suppose we are taking a vector space in R3 or R4, right?
No, you are taking vector subspace.
Vector space. So say for example, vector space R4, okay?
So you are taking, so your vector space is R4, fine.
Okay, vector space is R4. Generally, we say that number of elements in basis is my dimension, right? Number of elements in basis is dimension, right?
Number of element in the basis is
dimension.
True. That is the definition.
Right.
Definition of basis.
Yeah. So every time if my vector space is R4, so every time my basis will be having 4 elements, or it may have less than 4 elements.
No. You cannot have a basis of less than 4 elements. Okay. So that is one of the statement. Actually, all cardinality of all the basis of a vector space, they are same.
But sir, in video lecture like 4.4, I can say a timestamp also. Like R4 is there, but dimension is coming 2. And
no. Then you should take it properly. Okay, it's not possible. And as far as I know, there is nothing like this in lecture video. Okay,
but a subspace of R4 can be of dimension 2, right?
Yes, that is possible. So a subspace of R.
subspace can have less than 4, right?
Yes, sure. Like if you
But sir,
consider,
but when we say subspace, sir, subspace also belongs to same vector space, na?
Part of the vector space.
it's not. It's a as Mohan pointed out. It's a part of a vector space. It's not the whole vector space. Okay, it is a subset of a vector space.
So it may have even less number of elements than the maximum possible, right?
Yes,
Here,
true.
Here the maximum possible is 4. So a subspace can have even less than that.
Yes, true. Yes.
Okay,
Yes.
but the number of coordinates will remain 4. That's for sure.
Yes.
Okay. Okay, sir.
Yeah.
Sir, if you want, we can have this session later also, sir. Whenever you are convenient to have session.
No, like
that's a good suggestion, sir. Actually,
that will be, sir, because we are much comfortable, sir, with your actually. I know, sir, but actually we are more comfortable, and we have certain doubts, so we can ask you.
1 hour is already over, sir. So we can plan it.
Today, tomorrow,
that is fine. Like.
So that is actually the benefit of many people, sir. I really.
Your voice is now audible.
Yes, sir. Now, sir, it's so fine.
You can explain now, yes, sir.
Yes, good, sir.
No, again, okay. So the thing is, you will face the problem because
again it started breaking.
Problem I'm actually. Yeah, I know because actually I'm whatever I'm doing actually I'm doing with my this mobile connection. Okay, my broadband connection. I'm almost not getting any speed from that broadband connection. But again, I cannot do using my mobile connection. That is also not.
Most of the people agree that we can have it tomorrow, sir.
Just give me some 5 to 10 minutes. Subham definitely will join and he will
Yeah,
join.
am I audible, Subhasis?
So we can have tomorrow morning also. Yep.
Yes. Okay, Subham joined. So
Am I audible, Subhasis?
Yes,
Yes,
you
sir.
are audible.
Yes, sir. You are audible.
Yeah. Okay. So yeah. So today's revision session on week 7, right? For quiz 2. So that's right, Subhasis.
Yes, sir. It's a revision session, and we have.
Yeah.
So actually, we are starting from week 6.
Actually, I have
week 5 linear transformation.
Yeah. Correct.
Week 5.
So Subham.
Yeah.
So I just gave some examples of linear transformation.
Okay.
So that is what I have done till now. Okay, some 2-3 examples again, and I told him how you can check whether a map is a linear transformation or not. Okay, so you can continue from there.
Okay, so this is a revision session for week 7, but you started with the linear transformation, which is in week 5. Okay, that is.
It's basically I'm doing from week 6. It's not week 5. Okay, week 5 is also like linear transformation is also there.
Okay. So yeah, let's start now. Okay, let me start now. Let me share my screen. Then we will start the session.
Actually, I lost my connection. More or less, actually, I wanted to do. Okay, you try to complete as much as you can. Okay.
To ask for co-host.
Subham?
1 minute. Yeah, Subhasis, just 1 minute. Let me ask let me ask for co-host from Mahesh. Okay.
So yeah, so that book is pretty nice. Okay, so this linear algebra by Gilbert Strang. Okay. So, but okay, so again, like the book, whatever the book you are going to read for linear algebra, it's more or less, it's basically it's you have to deal with general approach. Okay, some general vector space. So it's not like that your vector space will be in the form of some R square or maybe Rn. Okay, maybe it can be anything. Okay, some polynomial or maybe some function spaces. So yeah. So but that book is pretty good. Okay, you can read from there, and it.
Which book you're referring to? Let us know also.
This Gilbert Strang book. So Gilbert Strang by sorry, linear algebra by Gilbert Strang.
Okay, sir. Yeah.
Yeah, hi, Subhasis. Yeah, now I can share my screen.
Yeah, you continue. Okay. Yeah.
Hope my screen is visible and my voice is clear also.
Yes, sir.
Okay. So you can start your, you can start asking your doubt.
Like we are asking like basics actually. So we're starting from week 5. So what are the basic concept like the linear transformation? So all these things. So sir was taking step by step. So that's how you can also like start the linear transformation and whatever topics are there.
Okay. So
He started explaining those two properties, additive property and scalar multiplication. So we were at that point only.
okay. Property of a linear transformation, right? This is
Yes.
okay. So
Sir, are you there? Sir, are you there?
Am I audible right now?
Yes, sir, but screen is not visible.
Oh, I don't know. Okay. Okay. Now my screen is visible, right?
Yes. Yes.
So I wrote just now this function. This function is a linear transformation? The vector space, you can say domain and codomain is R2.
No, sir.
This function is linear transformation, is it?
No, sir.
No.
Not.
No, sir.
No, sir.
Why this is not a linear transformation, or is this a linear transformation? So why is it following these two conditions which I wrote here?
Put the rhythm zero.
F of 0 is not.
It will not follow the scalar rule. Zero vector is not mapped to zero.
Yeah. So yeah, the best thing is saying to this function is will not follow these two conditions. You can check otherwise any linear transformation if someone is checking that this function is linear transformation or not. So it should map 0 vector to 0 vector. So but here is this condition is not following here. If you map 0 vector here, this will be 0 times 2 times 0. 0 means 0 0 here. Plus 3, which is 3. But
but it's also one conceptual doubt I have here.
okay, what is that here?
So mapping for 0 vector to 0 just by taking that 0 as such, but in vector space, it also depends on how the 0 vector is defined for that vector space, right? It's like in every case, you simply put 0 0 0 here and there, you put 0 and then see they are not matching. So that will be very restrictive, right? So we need to know the basic idea of what I'm thinking. I mean, like in a sense, a 0 vector of your transformation should map from one 0 vector to the another vector space 0 vector.
Yeah, correct.
It may not be 0 0 0 as such, right? Otherwise, you can just simply put 0 0.
Suppose this is R3, so it will be 0 to 0 to, like it is defined as here. So it will follow like this. Suppose this is so then you need to be it should be like this, then it will be clearly written like f of xy is equal to let's say 2 let's say I think I missed one thing there. Yeah,
one tuple
I missed there. Yeah, because of your concept, as you told, yeah, there is a conceptual. So I missed there one thing. It should be coordinate wise written like that. That should be like this. 2b plus 30 something. If that is like that, then it will be correct. Okay, so okay, I missed that. Yeah, but let me define that like this: 2x plus 1,
Yes.
3, and next one is 0. And suppose this is 3y here. Now, is this let's say this is R3 here as codomain. So is this linear? This function is a linear transformation.
No, still not.
Again, not because
the plus 1 is
yeah, here because of this plus 1. Again, if you
Yes.
check that
Still
0
not.
vector will be in R2 is 0, 0 and R3 will be 0, 0, 0. So if you so the image of 0, 0, 0 vector will be 1, 0 and 0, which is not a 0 vector in R3. 0 vector in R3. It's belong to R3 but not 0
Zero
vector.
to
So this
zero mapping is not happening.
yeah 0, 0
So my question is not this. My question is if since it is from V to W, if I am defining my zero vector in some other way in W vector space W, I'm not going for normal normal R3 R2. Because vector space, I want to define it in a different way. My zero vector in R in W vector space should be different based on some operation, right? So in that case, how do we check? Will all the questions will be like this? Like okay, you are
so
doing it from Rn to
want to check,
Rn.
you have to yeah. If you want to check, this is the only criteria to check that function is a linear transformation or
Okay.
that is a basic thing. Otherwise, suppose the linear transformation is like R2 R3, still that will work. Also checking as a zero vector is it's mapping zero vector to zero vector or not, still that will also work. Okay, so like neglecting the option, you can check that this linear transformation, this function is linear transformation or not. You can check one by one, just putting the zero vector in as an input and getting output. What is that zero vector or not? Sometime it can be zero vector. Let me define like this from R2 to R2. X, Y, and Y. Sorry, this is. So you can see that it maps zero vector to zero vector, but this is not a linear transformation. Then you have to further, you have to check these things.
Correct. Yes, yes.
Okay. But the only criteria to checking a function is a linear transformation or a map is linear transformation or these things we have to check, these two criteria. Okay. So
this question.
Now you can ask your like whatever I just now I got that I told you, like you said, property of linear transformation. Anything else conceptual or
We can proceed further, sir. After this, we can proceed further, like kernel image and all this.
okay. So just 1 minute. Just 1 minute. Yeah, I'm trying to get a slide, but I don't have any slide. Okay, let's start. Okay, no matter.
Hello.
Yeah.
Hello.
So,
Hello. Yeah. So Subham, I'm actually talking with the student. So do we have any session tomorrow 7 p.m.?
No, sir. Tomorrow is the deadline, so we don't have any.
Tomorrow is a deadline, right?
Yes, sir.
Sorry.
Sir, yes, sir. For those courses whose quiz 2 is not allotted.
Okay, so I guess yeah, hello. So I guess yeah, as
You can have it on
already
Thursday,
we have
sir.
spent
Sir, tomorrow afternoon.
a lot of time on all these things, like without doing anything basically. So we are planning to reschedule the session. Okay.
You can have it on Thursday, sir. Thursday.
We can have tomorrow morning also, sir. We can have tomorrow early morning,
Sir,
9:30.
not tomorrow, sir. Tomorrow we have week on Python submission. We have graded assignment tomorrow. I think Thursday would be better. Sir. Tomorrow we have,
Thursday, no other class.
Just
Tomorrow,
just
sir.
give me
On Thursday.
so you have exam on
Sunday, sir. We can have it on
13th.
It would be
Thursday.
good. If it will be
What is the problem tomorrow? There is
Sir, we can have tomorrow, sir.
I
We have
think
weekend.
tomorrow is fine.
No, sir.
What about
Tomorrow.
okay?
Why-
So
why tomorrow?
Sir,
again
tomorrow we have
okay, so okay, just a minute. Okay, so just be quiet. Okay, so my question is whether if you have problem, just then only you tell, otherwise no need to no need to say anything. Okay, so my question is what about so tomorrow evening you are saying you have some Python
Yes, sir. Tomorrow is the
lesson.
deadline for Python.
Tomorrow we have submission.
So tomorrow will be a problem, sir. That's why we are requesting for Thursday. Tomorrow we have graded assignment submission.
No,
for
you
Python.
have another session on 11th, right?
Yeah, Friday. That's on Friday, right?
Yeah, so you are saying we'll take one session on 10th and another session on 11th.
Yes, sir.
Yes, sir.
Tomorrow morning we
Tomorrow
can
it is
take, sir.
better, sir.
Tomorrow morning we can take, sir.
Tomorrow it is better, sir.
Tomorrow morning is also better, sir.
Tomorrow morning is fine.
Yes,
sir.
sir.
Tomorrow
9:30 is fine, sir.
Sir, we'll have to do Python, sir. There are many
No,
who have already done Python.
No,
We need to submit.
do you have Python session tomorrow morning?
No,
No,
sir.
no,
We
no.
have to submit, sir. It's not about sessions. Sir.
No,
about
it's
submission.
no, it's
We
not.
have to-
No, it's not a issue. Like session probably will spend maybe 2.5 hours. So no, I'm just asking whether you have session or
We don't have session.
No, sir. There is no session, sir.
okay, fine. Okay.
So we may plan for tomorrow morning, sir. That will be good.
Yeah, like
so that we will have enough time to submit Python as well.
yeah. So yeah, that is fine. Just okay. So let me discuss and probably we'll send you some kind of announcement. Okay, so
Because for
so
people who are working, it might be difficult, sir. That's why now we short time.
sorry. No,
If they're
so the
working-
thing is okay. So the thing is no, I don't. Okay, so the thing is okay. So see, this is not a good excuse. Like you have to do all the assignment at the day of the deadline. Okay, so certainly this is not a good excuse. Okay, so if you are saying tomorrow is the deadline and I will start doing all the assignment tomorrow, then certainly it's not a good excuse. Okay, so my concern was whether you have some session tomorrow morning or
No,
not.
we don't
That is
have any
what-
session tomorrow.
Sir, we are
tomorrow, sir.
working and managing time, sir. I'm not saying I'm going to sit down and do it tomorrow, but
No. See, the thing is, okay, so you have to understand that, see, the main problem, what I see, I don't have any problem of taking session on Thursday, but there is no point of taking two sessions on two consecutive days. Okay, so that is what so if I'll take session tomorrow, then you can study something, and then again you can study and ask your doubt in the next
Yes,
session, so that you will get some time.
Correct, sir.
Yeah, actually, sir.
Absolutely.
It's not like that I have problem on Thursday. Okay, I'm whatever I'm doing, it's basically it will be more convenient for you.
Sooner it is
So,
better.
okay.
Sir.
So then
Okay,
plan the
okay.
session not on the morning. Can we plan the session in the afternoon, sir? 10 to 2, 10, 12
No,
to 2.
afternoon. Okay, either it will have in the morning or it will have either it will be in the morning or it will be in the night. Okay, so I don't think we'll take in between.
Morning
that.
it is.
Sir, morning is good. I
The
think.
morning it will be good. Yes, sir.
Okay,
sir,
okay,
in
okay, okay.
that case, mornings are not nights are not night.
The morning can be the session.
can-
8 or
Yeah,
9.
yes. Yeah. Just okay. So okay, let me discuss with the respective person, and I will certainly send you announcement, and mostly we'll try to do it in the morning.
Sir, are we getting the mock question answers?
Yeah. It's already, we have prepared the solution. Probably we'll upload it maybe today or hardly tomorrow. Okay, it's already done.
Yeah.
Okay, I'll check about this. Okay.
Thank you, sir.
Okay. Sorry. Yeah. Sorry, everyone. Yeah. Basically, yeah. So.
No problem, sir. No problem.
Yeah.
No issues.
Okay. Thanks. Yeah.
Okay, thank you, sir.
Thank you,
Sir,
sir.
week
Yeah.
10 and 11 deadline is extended or not?
Sorry.
Sir, we got a mail from SATS2 that week 10 and 11 deadline is extended. So I'm asking, is it same for maths 2 also?
Yes, math 2 is extended to 20th, no?
As far as I know, week 10 deadline is 20th, and week 11 deadline is 23.
Yes.
Okay.
Yes.
Yes.
Okay, sir. Thank you.
Okay. Okay. Thanks.
Thank you, sir.
Yeah. Thanks.
Thank you, sir.
Yeah. Thanks, and sorry to everyone. Yeah.
Thank you.
No problem. Thank you.
Thank you.
Sir, we'll get a notification, right? Regarding tomorrow's session.
Yeah, we'll get the mail about the session.
Okay.
You will get informed.